Good morning and welcome to the last day of the conference. I hope the last 2 days have been everything that you expected and more. And I hope the panel discussion yesterday got a lot of ideas going and conversations started. So the two sessions for the last day are going to be chaired by the two conveners of the conference. And the first session will be chaired by our very own Dr. Arvind Madhyastha, one of the two men behind this conference.
Good morning. Welcome. The final day of this conference. Yeah. So in the morning session, we have one plenary by Patrick Faulkner, and two lead talks, one by Praveen, another by Dinazar, and four short talks. First talk by Patrick. Patrick is an associate professor of archaeology at University of Sydney. His interest lie in the field of coastal paleoeconomies with a principal focus on the tropics. He is also interested in Australian archaeology, zoo archaeology, taphonomy, human ecology, economics, human environment interactions, and technology. He'll be talking on recent archaeological research on Sri Lankan South Coast. Over to you.
Thank you. Thanks very much. Good morning, everyone. I'd just like to thank the conference organisers for the invitation to be here. This has been a fantastic few days. I've thoroughly enjoyed myself. As someone who probably represents the mixed bag for the conference as an archaeologist, hopefully, maybe a slight apology. It may be a little heavy on the archaeology, but I'll try and bring it back to the malacology a bit as well. Secondly, just to acknowledge my co-authors on this presentation. This is a large collaborative project being run in Sri Lanka that was started early last year. The field work was really only initiated early this year. So, you know, these people have made a substantial contribution to how the project has developed and will be developing over the next few years. Sorry, as an archaeologist, obviously the kinds of research questions that I'm interested in are very much archaeological in focus. So the broad question that I'm usually most interested in is how we as a species interact, engage, adapt to the environments in which we live. So this quote from Robertson Stewart about effectively human behavioural plasticity, how we adapt rapidly to different kinds of environments, is something that I've been thinking about for a long time. These two authors weren't the first people to propose this idea, but I think it's something that relates to us as a species, particularly when we left Africa 100,000 years ago and started to disperse across the globe. And that's really why Sri Lanka has become a focus for my work. So just to put what I've done over the last 2 decades into context, I've worked in Northern Australia, in New Guinea, Madagascar, the Comores, the Mafia and Zanzibar archipelagos, into Kenya, Oman and Jordan. But now my principal focus is really working in Sri Lanka, focused in South Asia. And Sri Lanka is kind of key to the story of human dispersals. It sort of sits centrally between Africa and our route out of Africa and then into Australia 65,000 years ago. So South Asia is, I think, particularly important in terms of our story as a species. How that actually relates to malacology, the antiquity of human use of molluscs, we've got really good evidence in South Africa, cave sites down on the Southern Cape, with the exploitation of marine molluscs 120,000 years ago. There seems to be evidence of land snail exploitation. The authors are saying 170,000 years ago, but at a minimum 70,000 years ago. Freshwater molluscs, pre-Homo sapiens, really kind of tantalising evidence 400,000 years ago, over in Island, Southeast Asia. But really, the most firm evidence we have is probably a good 38,000 years ago. Right? Think about these as minimum numbers. Okay, we as a species have been exploiting molluscs for pretty much our entire history. And I think this is why they're important. For the work that we're doing in Sri Lanka, they're really key to understanding early human occupation and engagement and adaptation to different kinds of environmental conditions. Okay, so the sites that we're looking at for this project lie predominantly in the southern half of Sri Lanka. And initially we were going to be looking at a range of different previously excavated sites that had really good mollusk assemblages. That hasn't quite worked out. So what we're really focusing on at the moment is looking at, wrong button, there we go. So Fahi and Lena, which is situated here, that's the oldest known site in Sri Lanka at the moment. It's in the wet zone upland rainforest dating to 48,000 years ago. Okay, when we think about what we know of human occupation in India, that's quite late. Okay, humans have been in India for much, much longer. So at least back to 70,000, and then we've got earlier hominid species in India as well. Right, so again, I think we're looking at minimum ages for humans being in Sri Lanka. We've got another site over here, Nilgala, which we're hoping to investigate, and a few other deposits around through this area here, really kind of focusing on environmental interfaces. Okay, so where these sites are actually kind of sitting at the edge of environmental zones as they are now. So as environment climate fluctuate, we're going to be getting changes in terms of assemblage composition and structure of occupation. Okay. And down on the coast, number 7 down here, working down in Bundala National Park. Right, so these maps are important because they show us the environmental structure for Sri Lanka as it is now, but it wasn't always that way. Right, so we need to really understand what the environmental and the paleo-environmental context is for humans in Sri Lanka. And I think that's really key in terms of looking at the molluscan assemblages, which in terms of archaeologists, hasn't really been a primary focus for a long period of time. Right, so briefly, just want to talk about Farhian. This was one of the sites that really stimulated my interest in Sri Lanka and in South Asia. I started working with Oshan, who unfortunately can't be here with us. He had to go home last night, in 2017, while he was doing his PhD at Max Planck. Started looking at some of these assemblages, and then over the years, we discussed working together in Sri Lanka. So as I mentioned a little bit earlier, Farhian Lena is the oldest known occupation site in Sri Lanka. So way up high in the mountains, in the rainforest. Excuse me. With quite a, sorry, this is where the archaeology comes in. With quite a deep and long sequence. But importantly are these ages. Okay, so 48 to 34,000 is the lowest occupation. We then have quite a large gap to the terminal Pleistocene, 12 to 13,000 years ago. Early Holocene, 9 to 8,000 years ago, and then a mid-Holocene phase. All right, so this is great. We've got this punctuated sequence of humans occupying the rainforest in Sri Lanka 48,000 years ago. Other early rainforest occupation sites are in places like Borneo, near Cape. So Sri Lanka is really important in this context. What's happening in between? Right? So we know when people are in this area, it's wet. When they're occupying this site, it's wet, it's humid. What's happening in between? We don't really know that at the moment. And that could be key to thinking about how people are moving in and out of what have been seen as marginal environments over a long period of time. I'll get to the shell shortly. All right, so from Farhian, within these sequences, we've got what seems to be a predominant focus on small arboreal animals, primarily primates, with small amounts of larger mammal species. These are the 3 primates that occur more often than not within the Farhian assemblage. So people are actually hunting these things with bow and arrow technology back to 48,000 years ago. All right. When you're hunting animals like primates up in the canopy with a bow and arrow, the chance of failure is absolutely enormous. Right? It doesn't matter how good you are as a hunter. Right? These animals move fast, they're small, okay, and they're high up in the trees. So the question that always came to my mind is, what are people doing when they fail? And it's this. Okay, so within this assemblage, we have a considerable number of Acavis, okay, land snail species, and we get Paleodomus as the freshwater mollusk. So I think what people are actually doing is they're using the mollusks as well as plant material, basically to buffer the risk of failure while they're hunting, but also as a staple in the diet. Okay, so these become maybe not the most important part of the human diet in this area, but they become a key ingredient in the overall economy, the overall diet of people during the Pleistocene and then through into the mid-Holocene in this rainforest zone. We have started looking at some of this material. Dinazad and some of her colleagues have done some analysis of this material previously. So this will be part of the next phase of research, is to look more closely at this material, particularly the Avis and the Paleodomus. There's also Cyclophorus and a few other species within this assemblage. And really look at not just the taxonomy, but also thinking about things like taphonomy, so modification of these species. Do they go beyond just a dietary importance? Right, so that's all out of whack. So what we get here within the technological assemblages are bone tools. So people are making arrows out of monkey bone that they're then using to kill other monkeys, eat them, use the bones to bring down more monkeys. We get stone technology, as we see here. We also have marine shell being transported from the coast into this site 48,000 years ago. All right, so discussions about human adaptations to rainforest environments. That's important, but as a part of that broader spectrum of behavioural plasticity and adaptation, I don't think we necessarily need to see a specific adaptation to rainforest because rainforests would have been encountered along the way into Sri Lanka. But what this shows us that people are also on the coast, however that may have looked 48,000 years ago. Okay. And the people in the rainforest are interacting with the people on the coast, transporting Conus species shell beads, and Nacerius shell beads as well. So these have been purposefully perforated and likely threaded for suspension. So they're being worn. This is a Cyclophorus that I recorded about 6 years ago now and need to revisit. That's from Farhian. So we can see with this one, likely people are eating these because they're a decent sized mollusk. There's very little indication of burning or cooking on these shells, so probably a low heat. But the important thing with these specimens are these holes near the aperture. These aren't natural. If you look at the morphology of these breaks. All right, so it's been perforated. There's rounding on the edges of those holes, so they've been worn, and there's pigment that's been applied to these. So molluscs are important in this context because they're not just food. There's also some kind of potentially symbolic value to them as well. And people always talk about marine molluscs as being important symbolically. What we're getting within this deposit is a hint, okay, that it's more than just the marine. Okay, the terrestrial molluscs are also important in this context as well. Excuse me. So really kind of looking at that evidence, I guess some of the biggest issues that we think about relative to the kinds of questions that I'm interested in and how I approach the malacological record from these deposits is that we have good sequences that relate to specifically human occupation. So those faunal assemblages have been analysed within not the entire deposit and not the entire sequence, but where there's been a density of radiocarbon and OSL dates. So they're dated deposits, right? Which is why I was sort of saying earlier, what's happening in the gaps? Are we seeing abandonment of that site and people occupying other sites within the rainforest? Okay? Within a mobility strategy, moving down out of the rainforest, back up. Are these environments fluctuating? And if they are, how severe is that fluctuation? Is that forcing people out of the rainforest into other environments? We have isotopic data from the vertebrate faunal remains and from human burials from this deposit, but again, they sit within those dated contexts. So environmentally, what we know is that this is a wet rainforest. Right? That doesn't necessarily strongly indicate that there's stability within that ecosystem through time. So the key for us is to look at the gaps within that sequence. And the way we can actually fill that gap is through the molluscan assemblage. Right, so we can look at the interfaces, I guess kind of the layer between the layers, looking at different potential land surfaces that may not relate to human activity, and potentially have a look at what species are being recovered from those parts of the deposit. Okay, that may then give us a level of a natural control relative to what we're seeing within the human occupied sections of that deposit. Given that we've got isotopic data from vertebrates, so both fauna and humans, I think key to really thinking about the broader ecosystem context and potential paleoenvironmental change within these sites and within this area is to apply the same kind of techniques to the invertebrates. So then we've got sort of multiple lines of evidence that give us an environmental signature. Okay, so stable isotopic analysis on, hopefully, still to be determined, but hopefully both the terrestrial and the freshwater molluscs. Okay, and then we can look at how these things are running in parallel. Right, and I think without that, we don't really get a good sense of what's happening within this environment. For me to be able to understand human behaviour, we've got to understand the environmental context. Right? And as I've said a few times already this morning, the key for us in terms of determining that and clarifying what that environmental context is the molluscan assemblages from sites like Farfigno. Right, so that's kind of a little bit of introduction to the bigger themes with a case study site to set the tone, I think, for what we've been doing this year. Okay, so we sort of shift focus away from the rainforest down to the south coast of Sri Lanka. We've been working within Bundula National Park, which is down in the Hambantota district, for the last 12 months and for a little bit of time before that. And within these sites, within this area, we're mostly focusing on the marine evidence, really kind of looking at human coastal occupation. But again, similar kinds of issues, similar kinds of themes in terms of really trying to understand what that environmental context is. Slightly different, the chronology down here doesn't extend to back to the same kind of time frame that we see within the rainforest. Really what we're looking at here mostly is mid-Holocene, roughly about 5,000 years. But then that adds a whole range of interesting issues into the environmental mix, particularly in terms of post-glacial sea level rise and stabilisation. Right? And then what effect that has had on nearshore habitats, faunal composition, and then that translates into human exploitation and occupation. So this is just one shot of the area, one part of the coastline in Bundula National Park. Okay, just a map to show you where the site is down here. Okay. So relatively, I guess, kind of shallow in terms of the shelf in some ways. Relatively steep drop off, and then we've got a coastal plain probably during the LGM that would have extended up to about 20 to 30 kilometres out to the old shoreline. So then after the last glacial maximum, as sea levels rise, which is what we're seeing here. Okay, rapid sea level rise up to the mid-Holocene about 5,000 years ago. And then a series of fluctuations in sea level. So this was determined from this part of the coastline, actually in the late 80s, early 90s. This still needs to probably be worked on a little bit to really kind of clarify what that sea level curve is like. All right, but these these peaks and troughs, potentially above present levels, are kind of important. You know, we think about marine molluscs and where they live and the nature of their habitats. If we're seeing pretty substantial fluctuations, we're seeing shoreline sort of pushing back and out again. We've got potential processes of progradation and sedimentary input into these environments that are important for understanding species distribution and habitat structure. So getting a handle on these kinds of processes are quite key in terms of thinking about environmental context and human occupation in this area. And more broadly, right across that region, sort of extending from southern Sri Lanka, the sea level curve, it's a little bit different depending on the nature of the evidence being used and where that evidence is coming from. But our envelope for sea level up to about 2 meters, 2.5 meters above present seems to stand relative to the earlier Catapoda sea level curve. So that's quite interesting. All right, and this figure just gives a bit of a synthesis of the environmental context as we know it now. So sea level curve here for Sri Lanka. That's the global sea level curve. All right, so during the terminal Pleistocene, we see a bit of a decoupling in terms of what the global sea level curve is suggesting relative to the evidence from southern Sri Lanka. That's not so much of an issue for the work that we're doing down there at the moment, given that most of our sites likely fall within the last 5,000 years. But that's something that we'll be aiming to clarify as well. But importantly, in terms of looking at these environmental phases, again, we've got massive gaps within this sequence. We know down on this area, which is a dry, arid coast at the moment, that it wasn't always that way, that we've got alternating phases of increased humidity and aridity. But where we actually kind of get most evidence, particularly for shell deposits on this coast, sitting here, we don't really have a good handle on what was happening climatically at that period. So that's something that's really important for us to really think about in terms of structure of that environment and how people are engaging with it. Right, lots of shell deposits that pop up within this area. Okay. What we see in places like Kalimalala, which is about 15 to 20 kilometres inland, depending on the area. We get shell deposition that extends way back into that area, and that likely relates to those processes of sea level rise over the last 5,000 years. We're getting storm surges that are pushing shell from the intertidal and estuaries up into the inland parts. So natural deposits like we see here. We know that in this part of Sri Lanka, there's a history of tsunami activity as well. So that's something that we need to take into account. That can have a pretty devastating effect. We also have a significant amount of human disturbance of both natural and cultural shell deposits within this area. Right. And this is one site that was excavated, I think in the mid-90s from memory. Sitting underneath a paddy field, was reported to the authorities because there were human remains in with the shell. So the shell was being mined to be sold on for line production. And then we've got a rescue operation, excavation, initiated by the Government Department of Archaeology to recover those human remains. But this is kind of significant, I think, in terms of what we're seeing with shell deposition, because it sets the tone for what we see across that southern coast. So these deposits are quite substantial, and you can just see it in that section of the excavation. So where that brighter white layer is, right through to the base is dense shell within that deposit. Right, and work down on this coast has largely revolved around arguments over natural deposition, Chenier formation, tsunamis, storm deposition, versus human occupation and deposition through human consumption and discard. So unfortunately, we're seeing a lot of site destruction, as we're seeing here, as a result of that kind of debate. And there's generally an assumption that most shell deposits are natural as a result. And this is just to show you what the burial from one of the burials from Mini Atalaya looks like. Okay, so this was recovered as a block, and you can see, hopefully, effectively that entire matrix around the human burial there is shell. And it's predominantly Meretrix casta, which is a backwater lagoonal estuarine bivalve. Right, so that then kind of links to one of the sites that we started looking at a few years ago, which was Bundula Pataradula. This site was dug in the 1970s by Sirunda Aniogla and then re-excavated by Oshan in 2019. Shell deposit is here. It dates to about 5,000. As I said, most shell deposits in this area date to about 5,000 years ago. And then we've got a series of thermoluminescence ages that at this point haven't been confirmed. Okay, so as I said earlier, 48,000 years ago for earliest confirmed age for human occupation in Sri Lanka. This date, roughly 70,000, is yet to be substantiated. Right, so Bundula Pataradula sits quite high. Okay, so relatively precipitous coastline, okay, dropping down into largely rocky intertidal as it is now, okay, jumping up, and then we've got back in this area here where you can probably start to see the red coming through these earlier geological formations where we see, particularly at the base, Paleolithic evidence. So this site sits roughly 14 metres above present sea level. Right, and this is what the site looked like on completion of excavation. Right, so 3.5 metre deep excavation in 2019, but key for the kind of work that we're doing down there is this lay here. Okay, so that is pretty similar in terms of composition to what we see at Mini Atalaya where that burial was excavated. All right, so this is a very, very dense shell deposit ranging between about 30 to 40 centimetres in depth. Okay, and you can see that again here while it's being excavated. All of the white that you see below the shell deposit, that's not shell. There's no organic material below the shell midden. Okay, so this is all kind of carbonate and stone. All right, so this kind of gives you that perspective from where the site is now, dropping down to the coast. All right, so lots of interpretations at odds for this deposit. Some people have said it's human in origin. Other people have said it's natural. There is nothing about this site that makes me think that it's natural. It's 14 metres above sea level. The amount of energy that it would take to pick up that amount of material and drop it 14 metres above present sea level, right, up over the edge of this precipitous coastline with nothing else but shell in it would be enormous. We're looking at a tsunami scale event in terms of the amount of energy. That water would be picking up everything within the intertidal, okay? Boulders, you know, all sorts of rock, potentially coral, pumice, pretty much everything that wave sweeps through would be picked up and dumped here, and we're just not seeing that. All right, so that excavation was about 4 by 4 metres in 2019. We analysed 2 squares from this deposit. This is Marty, my current PhD student working on these sites. What we get is predominantly Meretrix casta. So just have a look at the number of individuals from 2 1 by 1 metre square. So just shy of 130,000 individuals. Meretrix casta represents 92% of that deposit. This is spectacularly monospecific. And then we get minor numbers of small intertidal gastropods and other Veneridae that appear within this site as well. That dominance of this species is really interesting. Humans, when they forage across the intertidal zone, generally tend to sweep. Okay, they'll go across habitats, right? And they'll take a lot of almost everything that occurs within those environments. Okay. What we're getting is such a dominance of an estuarine bivalve that raises, I think, a number of really interesting questions. This species occurs down on the southern coast now, but in not massive densities. The sheer dominance of this taxon and the dominance of this taxon in every shell deposit on the southern coast, I think hints at particular kinds of environmental conditions. I think as sea levels are rising and potentially when they're stabilising, even within those fluctuations, it's creating certain types of habitats that are enabling this species to proliferate, to become biomass abundant. And we do see this in a number of different areas, other parts of the world with different species. I was seeing it in Northern Australia with Archidae bivalves. And then once sea levels regress and stabilise, those environmental conditions disappear. They don't disappear as a species from this area, but their dominance does. Okay, so we then get a shift. That's what I think is happening at the moment. All right. So what I've put here is just some basic descriptive stuff in terms of the structure of this deposit. Nothing that we're seeing on here suggests that it's natural. Taxonomically, in terms of breakage patterns, wear patterns, this stuff isn't being shifted by high energy. And all of the weathering is in situ for the shell here as well. All right, so to then kind of think about, if we're looking at human exploitation, how do we then characterise that? Okay, so one of the things that we've done is to measure a sample. We're not going to measure 130,000 individuals, but we've measured a sample from each 5 centimetre level spit. So it was dug in arbitrary levels, right? Roughly about 12% of each spit we've measured. Right, so usually within archaeology, when you're looking at this kind of morphometric data, people will interpret a size reduction quite simplistically. It'll be interpreted as being an increase in predation pressure through human activity. And we all know that's not always the case. That's far too simplistic. I think what we are seeing is a size reduction through time within this deposit, but that's probably not the most important thing. It's really looking at that size frequency distribution as we're moving through that deposit. Okay. And I think that's actually kind of showing that people are harvesting intensively, okay, and basically that frequency distribution is shifting as a result. Okay, these things are infaunal, okay, shallow burrowing bivalves. So you can't harvest easily kind of just en masse. You basically have to try and pull them out of the mud with that burrow shallowly. But you can still mass harvest. And I think mass harvesting is what we're seeing here. And I think that's reflected in these size distributions. All right, so I think importantly, if we were looking at something that was natural, we would see, I think probably particularly down in the lower spit, something that would look similar to that in terms of a natural curve for size frequency distribution. But pretty consistently through this deposit, we've got a 15 mil cutoff. So there's a size threshold there, which we probably wouldn't be seeing if it was natural. The recovery from this material was pretty high resolution. So if we're getting juveniles smaller than 15 mil being deposited, we would have been able to pick those up and measure. And that's just another graph to show that distribution of these species in terms of their size. All right, so what we're then going to be doing with the sites that we excavated this year, which occur all around sort of this part. No, sorry, this part here of the park. So I'll just show you some of the photos from those excavations and then run quickly through what our plan is for this area so you can see what we're going to be doing. Okay, so sites here, this is Bundula Pataradula over here. Site here and here that we excavated, and then sampling of a canal down. That southern part connects that lagoon through to the ocean. These are the two sites that we excavated. 2 by 1 metre excavation. So you can see the depth of deposit here. Okay, so the archaeology is pretty difficult to find because it's all buried anywhere between 20 and 50 centimetres below the current ground surface. Right. But the shell deposits conform to what we see within Bundula Pataradula. Okay, so we're seeing very, very similar kinds of shell deposits and all dominated by the exact same species, okay, within this area. All right, so we suspect these will be probably about 5,000 years, again, just based on what we see within the broader area. And 5,000 years is kind of interesting because there are some natural deposits clearly natural deposits that have been dated, and they're falling into about the 6,000 to 4,000 year range. So, you know, and all dominated by the Merotrix as well. So there's something environmental going on in this area. The other area, so those two sites have been looked at by Marty for his PhD. So he's got a good 2 years of lab work and analysis ahead of him. Right. The other area that we excavated on was this canal. So this was widened about 3 years ago by the Department of Wildlife Conservation. So they brought in heavy machinery and they dug the edges of what I suspect would have been a natural waterway in this area, and they widened that, okay, to increase the water flow. All right, and what we see about 200 metres along the edges of this canal looks like this on both sides, and a crocodile, but the shell's more important. Okay, so that I thought was really kind of interesting because we're sort of grappling with these ideas of environmental shift and then trying to correlate human behaviour and potentially habitat structure and species abundance with those environmental changes. And what we've got in this area potentially represents both natural and cultural deposition. And I wanted to get a really good handle on comparative material. So I dug these two 50 by 50 centimetre columns in this area, and we've got 3 layers of shell here and 1 thick layer of shell there. That's about 50 centimetres. These sites are 50 metres apart. Or sorry, these excavation areas. So the depositional sequences are quite different within 50 metres. Right? And we've got variation between natural deposition through water movement as well as human activity. This, I think, is going to be quite interesting environmentally, where we look at what's happening in between these more dense shell deposits to think about that environmental context. Just some of the material that came out from the excavations. We only finished the field season 5 weeks ago, I think. So I'm still really tired. But we were recovering lithic material, so stone artifacts, more Merotrix castor than you would ever want to see in a lifetime. We were getting terrestrial vertebrates, not very much, but we've got evidence for deer and some kind of medium-sized mammal from the bone fragments. We've got fish coming into these deposits, so that's going to be interesting to have a closer look at that in combination with the molluscan evidence as well. Okay, so the fish otoliths here, we've got some type of catfish, as well as a drum or a croaker. And because we've been doing pretty high resolution recovery, we're doing flotation of the sediments, wet sieving of the sediments as well. We're starting to get out from the sorting some of the terrestrial land snail. Okay, so again, I think this will be quite interesting in terms of thinking about the environmental chain and that environmental structure here. All right, so the sampling that we've undertaken, so bulk sediment sampling, and again, this hopefully will be able to allow us to recover some of the smaller terrestrial molluscs from these sediments to give us those environmental indicators. I think that's going to be really, really important. We've got micromorphology blocks, which you can see Mike recovering here. These pick up the interfaces between the shell deposit and the upper and lower sediments. So there's good potential, I think, to recover small molluscs from those blocks as well. Flotation, which is something we did. Most of the flotation literature relates to the botanical material. There's been a lot of emphasis on that, but it's a really good way to recover small molluscan fauna, very, very small fauna. So we recovered systematically flotation samples from every excavation context, whether we think they're natural or cultural. Okay, so again, we're trying to build these environmental sequences using these molluscs as indicators. This was near Bundula Pataradula, so I just wanted to show this photo in terms of the kind of sampling that we've been doing. This is a 6.2 metre deep trench, so it's stepped down this erosion face. We systematically took sediment samples right through it. So that picks up all the changes in the sediments, in the layers, and hopefully again will allow us to look at those indicator species in combination with micromorphological blocks and pollen samples. So we're getting multiple lines of environmental evidence here to draw in to also thinking about the molluscan evidence, which we'll also do through coring of the 4 lagoons within this area. Isotopes, I think, are going to be really important within this context. So we've just put in a permit application to collect live merotric specimens early next year, so that we've got that modern baseline data for the isotopic analyses. Those samples will be going to Germany and to the UK for analysis. And we'll also be doing laser-induced breakdown spectroscopy to look at elemental ratios in combination with the isotopes on the merotrics. Again, so we can kind of have multiple lines of environmental evidence here using the shell. And I think probably one of the things that I'm really excited about, actually, almost more excited about than anything else, is all the areas that we're going to be working in, is that there'll be mollusk surveys being done, systematic surveys and transects that Dinazar will lead, to be able to really properly analyse the shell assemblages from these past deposits. We need to understand the structure of these populations now. We need to know exactly what's there. There have been some surveys done in some of these areas, but not all. So if we can combine those modern faunal surveys with what we're seeing archaeologically, again, that gives us an inkling of potential environmental and habitat change. And from what we've seen from some of the terrestrial molluscs recovered from the excavations, there may be one potential species that may not actually sort of live in that area anymore. So that will need to be clarified. One of the other things that we see within these deposits, not the ones we've excavated, but other ones, is a cavus. This is a dry zone area. Cavus is wet zone adapted. So are these shells being transported, or are we seeing environmental change and habitat shift through time? All right, and I think ultimately, because I still have 1 minute, what I'm really kind of hoping that this work will do is lead into some of the issues that people have spoken about over the last 2 days. Things like conservation biology and ecosystem management. We're working in national parks, in wildlife protected areas, and we're working pretty closely with Department of Wildlife Conservation, at least on the ground. So, you know, we can start to develop that relationship and then hopefully build and flow that information upwards to the people that are making the decisions. You know, if we can integrate what we're doing with our modern survey work and the archaeological data, which gives a bit of time depth to the environmental structure and environmental changes, then hopefully that will allow people who are making management decisions in these areas to take that into account. Okay, last one, just the acknowledgements. Thanks.
Thank you, Pat. It's a time for one quick question.
A quick question. So you mentioned that these mercenary, the bivalves, I mean, most of these pictures showed a disarticulated bivalve. It's one valve. If they are natural and they are not getting transported a lot, how do you explain the dominance of single valves rather than articulated valves?
Well, that's one of the arguments that I'm making. People have been saying that there's a high proportion of articulation within these deposits, and we're seeing less than 2% articulation. So for me, that argument doesn't hold up because the vast majority are disarticulated, and that probably relates to that processing and consumption and then discard.
The second question is, do you also find drill holes on those shuts?
Very few. Very few. I think from that 130, close to 130,000 valves, there may be 10 that show evidence of drilling predation. And those drill holes conform to the Niticidae sort of pattern, but it's rare. It's really rare.
Yeah, because that might be kind of used as a sort of a supporting evidence that it's primary. I mean, generally the frequencies are much higher.
Yeah.
And if it's sort of restricted in.
Yeah. So what we've been doing is pulling together all of that kind of taphonomic evidence, and really trying to show that the nature of those taphonomic processes, the condition of the shell, things like predation patterns, fragmentation, weathering, none of it looks natural. Yeah.
Thank you, Pat.
Thank you.
Next talk is by Ravi. We'll be talking on global time.
Okay,